Hello, this is Richard from animate.com, and here's a short video about how to make such abstract motion design animations using some modifiers in Blender and Eevee. Most of all, we used some displace, edge split and smooth modifiers, and the basis for using such organic remeshing of your base mesh, in this case it's an icosphere, was the Vertex Weight proximity modifier. So let's start off. As I said, the base mesh was an icosphere, so I'm going to add an icosphere with hitting Shift A for the add menu. Right away I'm going to activate some shortcuts so you can follow and I don't have to always say each shortcut I'm hitting. I will lock the camera to the view so that I'm going to choose my left-right axis right away as the x-axis. And in order to dynamically change the influence of modifiers for the displays and smooth and everything we're going to need, we will use the proximity between two objects. In this example, I'm just using an empty as a helper object, so I'm going to add an empty plane axis and set the location to 0, 0, 0. But in order to let it wiggle automatically, I will add some automatic motion to it. So I will add the graph editor here, select the empty. I will add some keyframes so that I see the location channels in the graph editor, and on the right hand side you have this small arrow where we can add modifiers, animation modifiers, and in our case we want to add a noise modifier to let it wiggle along the x-axis. I will scale the noise up so that we have one wiggle, one bounce in about 25 frames. So I set the scale to 25. And the strength could be 1.5, so it wiggles, bounces 1.5 meters left and right on the x-axis. Okay? That's the maximum wiggle. Let's raise it even more to 3, then more often we will see that it's bouncing out. Now we can copy it here with this small icon and go over to the Y location and paste it. But in order to not have the same wiggle on both axes, we are going to offset the phase for the Y channel and the same for the Z channel. I'm going to offset the phase in another direction. So now we have a three-dimensional wiggle. It just moves automatically in all three axes. That's all we did in the graph editor. We're going to make the icosphere visible again, and yeah, the vertex weight proximity of course needs a vertex weight, so we need to add a vertex group to our icosphere. I'm going down to the mesh menu and to the tab of the vertex groups and add a group, and in edit mode we need to assign the vertices to the group. So I switch to edit mode, everything is selected. If not, just hit A once on your keyboard and hit assign. So each vertex is now added to the vertex group with a value, with a weight of 100%. Let's go back to the modifiers, and if we use the vertex group as displacement weight, we will see an even displacement all over the mesh. So in order to change the weights, the percentages of our displacement, we will now use the vertex weight proximity modifier. Of course, we will use that before we displace. So let's have a look at the order of modifiers here. First comes the vertex weight proximity and then the displacement. Let's look at the vertex weight proximity modifier. We're going to choose as vertex group our group we just added, and the target object in our case is the empty. We want the lowest value, 0% weight, at the farthest distance, and the highest value, 100% weight, if the empty is coming close to our surface. So we have to switch these values. And already you see that something changes here. That's because the displacement modifier already uses the group, and we are going to change the group now. So by activating the displacement modifier, we can already judge if the values we input here are good values, or if we should change something. You see that if I raise the highest value, 100% influence, to 0.5, and lower the other one, the whole mesh is changing at once. I don't want it. I want each vertex to be changing independently, and therefore I use the distance between geometry parts, elements, and in our case we're going to use the vertices as geometry elements to choose from. So again, let's raise the lower value to something like 1 meter or even more, 1.1, 1.5. I think 1.1 is good. And if we hit play on our keyboard, we see how it bulges out where the empty is moving. And that's the basis of our organic motion design animation. Now we already have a very organic look. We're not going to add a texture here, so that the whole mesh is displaced with the same strength. Only the vertex group is going to change how much it is displaced. Next, we will use 3 different icospheres, but all of them will use about the same modifiers. I want to split it right away, but only at the very, very bulged parts, because here we now can see higher angles between the segments than on the other side, where it's not displaced. If I lower the value of the edge angle right here, you will see that no, we won't see the edge split, because we can't see it in the shading. It's just done at the edges are split, but still at the same location. So how do we see that the edges are split and the polygons are actually separated from each other? Well, we use a smooth modifier, and the whole surface is now evenly smoothed, which means every polygon which is split will shrink down to its origin, to its individual origin. So if we raise our angle to something like 20, let's use 20 right away, we see that it looks like broken eggshells. Very geometrical broken eggshells, but maybe that's what we need. Let's raise it even more so that the back side of the icosphere is one single part, and the front side is breaking apart. In order to make a really big hole, I'm going to raise the strength of the displacement and try to lower the split angle to that one value where the backside tears apart. And maybe I want to lower the high value, the 100% value here. No, I want to lower, right, I want to raise the lowest value. That's the backside, the lowest 0% influence side. It has 0% influence if it's more than 1.3 meters away. This will lead to our splits to come farther to the backside. So we see more open areas in front. I think that's good. Therefore, I can lower the displace value again Doesn't have to be that high. 1.1 is good. And let's smooth down 5 steps. So you see the shrinking of the smooth modifier actually lets us look much deeper inside the sphere. And that's very helpful. If we just want to shrink down the split of parts, then we again can use the vertex group, because this has 100% influence on the split parts, and the unbroken shell still has no influence from the smooth modifier. Next, I'm going to add a solidify modifier, and again we can use the group so that the inner part of the shell, then the unbroken part, stays thin and only the broken parts get thick. And that's about it for the first icosphere. We're going to shade it afterwards, but right away we're done, and we can Shift D, enter, make a copy of that one. Now I want to show some wireframe on the broken parts. So how to do that? I'm going to delete the solidify. We see we can use some wireframe modifier, which also has a vertex group option. We're going to use it, and whatever thickness I'm going to use here, it will lead to very, very thin wireframes in the back side, while on the front side the thickness of our wire is visible. In order to see it better, I surely want the wire to come above the split parts, so I raise the displacement value. So that's the wireframe. Maybe we want to smooth it down. I would add a bevel modifier with 25% smoothing and uncheck overlap. So now we get nice segments that don't resemble the same polygons we already know from the icosphere. Let's uncheck it and see. Here we have a part where we only see the icosphere, while on the other side we see the wireframe appearing. Okay, and last we make a third copy of our original icosphere. Shift D, enter. And now I want to offset them. I want to make some split some chips on the back side, on the unbroken side of our sphere, just to give it some variance on this side also. So now we're done with the wireframe modifier, and we can add some chips flying around on the unbroken side of the icosphere. I'm going to duplicate, Shift D, hit enter the original icosphere, and the vertex weight proximity will be the same for that one as well. But this time I want to uncheck, or I won't use the group for the displacement. Everything should be displaced at a certain level. I will use the edge split, but with a far lower split angle. I want to split all segments, all polygons, and I will raise the smooth value to a very, very high level, like 30 times, and maybe even raise the factor to, let's raise it to 1. So we have an offset shape, and this smooth modifier is using the group. Let's add a second one that is not using the group. So we see that actually really every single segment of our icosphere is split because of the low value of the split angle. Okay, Let's make 2 steps so they're separated quite far. We already added a thickness, which is using the group. That's okay. Maybe let's swap this time the group influence, so that the back side is getting thickness and the front side, it's still present. There are still some very, very, very small parts of our split polygons, but they get no solidified thickness now. And in the end, maybe we want to also bevel these chips so that they look much smoother and not like displaced extruded polygons like they actually are. So again, no, this time I would use 15% and also uncheck clamp overlap. You see they are now getting becoming some small chips. Maybe the thickness is too high, 0.05. They're really thin chips, and we're done. Let's make the shading. I will change the timeline to the shader editor right away. I hit N to let the panel disappear. And first of all, I'm going to define the background. I would like to have some dark bluish variance in the background. For this, I'm going to add a color ramp to define the colors and a noise texture. I plug the noise texture factor into the factor of the color ramp and the color to the color of the background node. Let's add, instead of black, I'm going to dark blue. And on the other side, instead of white, let's make it very dark violet color. Could be intense, and it will be occluded by volume scattering, so don't make it too dark. It should come through the volume scattering also. Something like this. And because the factor of the noise will vary around the value 0.5, we can make some clamping. Just move both of these colors into the middle. So that's the background. Maybe we want some lower scale so that there are bigger flakes. And let's go to the object shading of each icosphere. The inner part of the icosphere, that should be some sparkling crystallized material. So I will make it very metallic and very specular, but I will lower the roughness so I get small but bright specular sparkling. And as texture, I will use a Voronoi texture. I raise the scale to 150 and add 2 nodes, one for the colors and one for the bump. Bump node, of course, is a bump node in the vector menu, and for the color, again, a color ramp converter. But instead of a factor, instead of the distance, I'm going to use the color, which is making color chips. It will vary some in between the... it will use the intensity of our cells. These are colored cells. And therefore we can vary along the ramp. Again, I would use maybe a dark blue, almost black. And in the bright areas we could use white or some reddish pink white, and in between I'd say some cyan. Let's lower this value again. It's already at 150, and we said that we are going to use the distance as the height of our bump map. I will lower it right away because this will be very, very sparkling already. Of course, in order to see the specular and reflection stuff, we should once go to the render tab, activate screen space reflections, and we already see much more detail in the surface because we get the actual geometry reflected. And for the chips, we'll use a glass material, so right away we're going to activate the refraction. Let's raise the trace precision to 1, and the rest is fine. Let's activate ambient occlusion and raise the distance to 1 or maybe 2 meters so that we get some influence between the objects in the ambient occlusion. And back to the modifiers so that we see which we have selected. I think that's it for the inner part. Yeah, right, we wanted to add some lights, so I'm going to change Ctrl-Alt-Q to the quad view, and I will move some lights around. Before that, I'm going to make it colored in a warm orange color. The first point light, it's on the right side above, and I will move it in front so I can see some more parts of my icospheres. To make 3-point lighting, I will use another one on the lower horizontal part. In front, you see small, here's the camera, so this is the front area. From that front, I will use a cold light. I'm going to the cyan blue areas and maybe just lower it to 2500 watts. It could be this should be the darker shadowy side. And to make some contrast, we can use a very bright 25,000 watts light, which comes from the above, so we get some rim light here in this area. About that. And maybe also on the other side, but let's stay pink here, reddish pink. Also with 25,000. So that's very, very high. If we activate bloom, for example, we should definitely use a high threshold level because the specular pixels have a very high brightness now. Here. And if we lower the radius, not everything in the picture is now blooming. Okay, now we have some lighting, and we can use these lights and the specularity to judge the second material. I would make it a golden cage. The wireframe should be golden. Here's the wireframe modifier stack. Something I would like to do is I would like to shrink it down. It's very thick. I think that's too thick. 0.05 would be nice. It doesn't change a lot. Maybe we should use a smooth modifier. Maybe, I don't know. Let's try it out. Yeah, it helps a little, but I definitely rise it above the bevel modifier. Oh no, no need to. Okay, let's use the smooth modifier at last modifier in the stack. And you see that the wires are getting thinner and thinner. I think that looks better. And and this will have a golden material. That's quite easy. It's an orange intense color. Maybe lower it to some brownish color. Let's go back to the shaded view. Uncheck lock camera to view to move in and see more of this. And we see some flat shading. Now let's use smooth shading for this object so we get more variance in the reflections. Lower the roughness. Raise metallic and specular to maximum. Or maybe not 1, but 0.5 so that the brown color still gets through. And that's it. No need to do any further steps for this one. Let's use a shader for the glass chips in the back. We activated screen space refraction for this one. And I would like to add a glass shader, but that's quite boring. You don't see a lot. So maybe we want some further subsurface scattered, some metallic, very transmissive principal shader added to that. But before we add it, let's think about how we shade it. Not pure white, that would be boring. Let's give it a layer weight and drive a color ramp with the layer weight. That means if we look perpendicular to the surface, we should see just the refraction. We can end here with the facing. Right, it's now black in front and white in the parallel areas. White in parallel. If we look through, we want to have the white, full transparent shading, and if we look along the surface, I would like to have some cyan coloring, but in the base color of the principal shader as well as in the subsurface scattering part. And we add this to our glass shader, to our refraction. Surely we want to raise the specularity and lower the roughness. And also lower. Right, because that's not glass, we don't need the white color. We may want to have some black. So that here in front, if we look on the front sides of our chips, we may just have the glass material. It will be very dark, and the cyan brightness only appears in the parallel areas where we look very parallel to the surface. Okay, so we see a little bit more than if we just used a plain glass material. There's a little more color variance in it. Looks nicer. So, still miss some light. Most of all, I want some light in the center of our icosphere, so we get much more information about the geometry. So let's add one. Let's add a point light, give it the location 0, 0, 0. That's exactly where the center of our that is the center of our icosphere. And let's do some contact shadows that it only illuminates the inner parts of the icosphere. Cool. So I think we're almost done. Let's add some pink volume scattering, and that might be it. I add a cube, give it also location 0, 0, 0. I raise it and add a shading, give it some volume shading and unplug the surface. Give it some pink color, maybe some brownish reddish color, looks warmer. and lower the opacity, the density, to 0.02. That looks nice. Give it some anisotropy, and in the volumetrics tab of our render menu, I am going to adjust the distance levels from 1 meter to a maximum of, let's say, 25 meters. I think that's pretty far away from the camera. Let's raise the brightness of the center because we don't see the rays coming out. That's a point light right here. It's 1560 watts. Is it true? Yeah, it's 000 location, so that's the centered light. Yeah, let's raise it to 12,000. And we see a lot of rays coming out. Maybe our bloom effect will exaggerate now, so I reduced the specularity for that one to something where I don't see a bloom. White color is nice, but I don't want the whole glow effect around. Be sure that this preview is not the same result as we see it in the render resolution. So we should definitely first check it with render resolution. I quickly raised the samples for shadow sampling. I would like to not see rays coming out in front where there shouldn't be some. So here are rays getting through the icosphere, the original one, because it's too thin. And what we want to do now is to raise the thickness on the inner shell of the icosphere. We can do so by using a second vertex group with a second vertex weight proximity. So I am going to change, let's use the wireframe mode so that we can see all the geometry. I'm going to the geometry, to the mesh menu, and add a second vertex group. Now we have to assign all vertices to this vertex group first with 100% weight. Actually, it doesn't matter because we're going to reset them anyway with our proximity modifier. I'm hitting assign for the group 1. Going back to object mode and to the modifiers. Now I'm going to copy the vertex weight proximity, and here on top of the vertex of the modifier stack, I'm going to define the group 1, change the 0.5 to 1 and 1.3, the lower and higher limit. And therefore I defined the opposite of this group for group 1. And why do we do that on top? Because that's the state where it's still a sphere and where we can define the proximity distances to the sphere. Everything that happens afterwards, especially the displace, is changing the distances of the vertices, right? So that's why we need a second group. We cannot do that with the first group down here. But now we are going to add some modifiers which will add some thickness in the inner part. So now we are going to add a displace modifier using group 1, and we just need a value of 0.1 or maybe 0.12, a very, very low value, and the mid-level stays at 0.5. And afterwards, because now we also raise the surface above, so we see much less of our wireframe. There is no wireframe now visible anymore. We're also going to smooth the whole surface until the wireframe appears again. Okay? But now we have no shadow coming, no rays coming through the shell because we just made it thicker. Let's check the animation if, yeah, the wireframe looks nice. Okay, and here also on the back side, maybe that's too much smoothing. so that the wireframe only appears on the edge where the parts are breaking off. So that's it. We can render this out and be happy with everything. Maybe I want the chips to be much closer to the surface. Somewhere here. And that's how we do a very sophisticated and abstract motion design with modifiers, only using modifiers in Blender. I'm wondering why the Vertex Weight proximity won't lead to a lot of motion design like this popping up on YouTube made with Blender. I think there is a very, very huge field of possibilities. There's so much potential in this modifier, and I hope I could show you some of this potential in this tutorial. I hope you liked it, and if you have any feedback, please let me know. Just use the comments down below. Hit like and subscribe if you want more videos like these, and check out my other products on BlenderMarket. I have some for weathering tools like UV Spectrum, where you can quickly shade your surfaces and add some scratches and stuff, or some erosion for landscapes. That's a kind of a landscape generator, or modifying your landscape with an erosion algorithm that will generate a lot of vertex groups and ready-made shaders to make rich environment, as well as very complex and sophisticated shader setups, node setups, to accelerate your shading and rendering, and introduce some spatial depth into your surfaces, so that you won't need to add particle systems or scatter objects on surfaces, but rather just shade them into the surface. So that's it for now. I hope you liked this tutorial and stay tuned for more. Bye.